So, what are we talking about today, Andy?
Another hot topic.
That's right, we're going to talk about temperature and cold things and about vapors.
Yeah, clouds, things like that.
Okay.
So, kind of feels hot in here.
Now, what temperature do you think it is?
What's the temp in here?
Room temperature.
Now, what temperature is it?
72.
Temperature. Anybody else got another temperature similar to that?
22 Celsius.
24, 22, yeah.
Celsius. So there's two different temperature scales. Why is temperature the way it is?
Now, what does temperature mean?
Well, it has to do with how fast the molecules in the air move. So Andy is a molecule. He's a very hot molecule, so it's moving very fast. I'm actually a pretty cold molecule, so I'm not moving all that fast. I'm just kind of just going around like so. So fast, hot, slow, cold.
That's right, that's all temperature is.
So what happens when we go into my speed here? What if we reduce my speed to stopping?
All the way to zero. How cold is that?
It's called absolute zero.
Absolutely.
It's the coldest temperature you can get to.
Yeah.
And it's about,
Oh, there's lots of ways to describe it. Negative 273
Celsius, or minus 460 Fahrenheit.
Yeah.
So that's even colder than Embarrassed, Minnesota.
Just a little bit.
Just a little bit. Maybe even colder than last weekend.
And there's another scale that we use that turns out to be more useful when describing, relating temperature to velocity. We don't use Fahrenheit, we don't use Celsius, we use
Kelvin scale. So right now, room temperature is 300 degrees in here.
Yeah.
Kelvin, or 0 degrees would be close to that.
So they could.
So we have some cold stuff here for you.
Absolutely.
We've got this is some liquid nitrogen, and liquid nitrogen is the air is made out of mostly nitrogen. It's got a little oxygen as well. And I'll take a flower. We got a flower here, just to kind of.
Happy May Day!
Oh, thank you. Yes, May Day. How many people have been out celebrating May Day today?
10 friends who have been out this morning at 5 o'clock. They're letting in the summer.
So we'll just take this flower here.
Get my info next to me.
Okay, only once again.
Come on.
No.
You can do it. No, you can do it.
Here's our flower, perfectly preserved. You can break it like a piece of glass.
Absolutely.
So, I mean, the air is pretty cold, or this liquid nitrogen is pretty cold. We can kind of demonstrate that by my balloon. Here's my balloon.
So, if you can liquefy nitrogen, that's what liquid nitrogen is, can you liquefy air? Well, let's give it a shot. There's air in the balloon. It's getting colder, it's getting colder. And colder.
So what's happening inside the balloon now?
Well, the molecules are not moving around as fast, right? They're slowing down. Need some Viagra. And so they're not taking up as much space. You can pack them in closer if they're not going around that fast, right? So the pressure is decreasing, it's being crushed by the atmospheric pressure. How you doing there?
In fact, you can reduce it down by the tongs of science we're doing here.
Tongs of science. So we have actually liquefied air just now. Now let's pull it out. Let's bring it back into the gas phase. Whoa! Here we go.
So we can now, the air has not escaped from the balloon, it's still inside there, but now, of course,
whoa!
it's a balloon animal.
It's a little bit here.
To Harry for being such a great sport all year round. So, we've also got, if you think about the cloud formation, clouds, we have,
You killed the cloud! So this looks a lot like a cloud, right?
so what's going on? What is this white stuff?
What do you see there? What is that?
This is nitrogen in here, by the way.
Liquid nitrogen inside.
Yes.
And we put into a gas. No, that's not.
No, that's fine.
What is this? What is the white stuff?
Right?
Nope.
No, we have some dry ice here too.
What is it? White water.
It's water vapor. That's right. It's condensed water vapor. In fact, condensation, which happens inside, if you take, if you wanted to form a cloud, for example, one of the things that forms a cloud, there's water molecules everywhere in the room. That's why when you talk, your voice doesn't dry out really quickly. If there's no water vapor, it'd be really problematic. And so there are two processes in making water droplets. There's one called agglomeration.
Let's see it. Agglomeration.
Agglomeration, so here's some agglomeration.
Hey, it's making droplets.
And they're going to build up the water, but there's a competing process called evaporation.
Evaporation.
So N is trying to make it go away, and if the evaporation process is faster than the agglomeration, you don't get water droplets formed. However, now if you lower the temperature,
Lower the
the
temperature.
agglomeration process wins, and you start to form small water droplets. This is what happens in cloud formation. If you look up what happens, if you look at a cumulus cloud, does it have a round bottom or a flat bottom?
Round.
Flat. It's got a flat bottom because that's the point at which the temperature goes down as you go higher, and when the temperature reaches the dew point is the temperature at which the water vapor is completely saturated. It's just ready to start to agglomerate into droplets. We start to form these droplets of water vapor.
And it's important to understand that water is transparent.
Yeah.
You're looking at me. You're looking through gobs of water right now. But it's in a gas phase, okay? But as soon as you agglomerate, as soon as you become liquid, then it scatters light all over the place. That's what white light is. So that's what has to happen to be able to see a cloud.
So if you take some other cold stuff here, we got some dry ice here. Dry ice is solid carbon dioxide. And we'll just take a little chunk of this stuff.
Whoa. Turn it in the water. What
Put it in
happens?
the water, and you fall asleep.
We see a cloud.
So this is water vapor. There's water vapor just above there, but because it's cooling down, it actually makes it condense right above the
It
top.
takes the water vapor in the air, condenses it, and you see it. It was there all along, it's just you can see it.
Now we have another version of that.
Here you can see a little bit of steam above the boiling pot, just a little bit, okay? A little bit of water. But what if we add dry ice to that?
Okay, so we'll add a little bit of dry ice and see what happens.
Let's go.
Whoa!
Thank you very much.